Friends, welcome to part 4 of our video presentation on chapter 9. In this part, we will continue talking about the SDLC framework, and we will concentrate on the construction phase. Now, construction phase has 3 steps: system design, system building, and system testing. And obviously, consistent with this waterfall idea, construction phase begins only after the system's requirements documents from the definition phase is approved by some of the key stakeholders. Again, if you think about it, it makes a lot of sense, because you shouldn't start working on something that is not approved by all the key stakeholders. Because if you do, if you work on something, if you work on features that are not essential, that are not required by some of the key stakeholders, it means you'll be wasting resources. So that's why you need to have the definitions document, requirements definitions document approved first. So we'll talk about system design, system building, and system testing sub-steps. Okay, system design. So here you're designing your information system. Although at this phase you may come up with some ideas or specific requirements in relation to the types of hardware and software used as a part of your information system, the focus here is on the logical design, at least in the initial, in the initial sub-steps of this broader phase. In other words, the focus is on the logic of things, how the components will work together. But eventually, of course, all those considerations will lead to a specific technical design. But you start first with logical models. So you start by designing structure and content of databases, let's say by creating ERD models. You also define programs and their interrelationships. Let's say using a DFD diagram, you define what are the key processes or applications that will be at work and how they will be related, meaning how they will exchange messages, what kind of data they will use, and so forth. Now, and then, after that, you may think about hardware and software components that will be supporting those logical structures that you define here. Now, this is a critical step from a quality perspective. There's a growing belief that quality cannot be quality cannot be achieved at the testing phase, where you try to identify and correct bugs. What quality experts are saying is that quality needs to be built in. In other words, your design, how well your system is designed, how simple it is, how elegant it is, how clear and unambiguous your data structures are, will define such important quality parameters as accuracy, reliability, security, robustness, and so forth. Okay, so you cannot just catch problems in relation to reliability at the testing phase. They need to be thought about. Those considerations need to be taken into account at the design phase. And you probably understand this idea that I think you can use cars to explain that. Some cars are just well designed, where components are well aligned, where the design is simple, and that prevents important problems from happening down the road. A key deliverable out of the system design step is a detailed design document. So you have all kinds of models, logical models, database models, models of processes, models of data. And then you have also physical models, physical descriptions of the proposed information system solution at the physical level. And then you may also have, detailed specifications for each program in the system, for example, in the form of a flow chart, and then some plans for the remaining steps of the construction phase. So here we have design. The blueprint of the system is proposed. Okay, the third step, system building. So this is where you actually produce the artifacts. So for example, you produce the software programs, you develop or enhance the databases, the files that will carry the data, and this is where you procure, meaning purchase, the new hardware that will support the software that you develop here. Now, documentation is very important here, because you need to capture what kind of components were used, how they were put together, so that other members of the project team can use this information in case they have any questions down the road, for example, during the implementation or operations phase. So you basically need to describe how the system was built, from which components, and what are the properties of those components, so that later on other team members related to this software project can use this information in their own work. So this is system building phase. Step. And then the last step within this construction phase is system testing. First, you do testing by IS specialists, meaning technical specialists, software specialists. They use the they use applications to see whether they have any bugs in them. Typically, the testing is done at the module level first, and then modules are assembled into subsystems and tested. So it's like a higher level testing. And then all subsystems are combined together and integrated, and you have this overall system test. So you start small at the module level, then combination of modules, and then at the systems level. Now, this is a very time-intensive step, and you probably know that software quality assurance is a big field on its own. People get degrees, or they get certifications in quality assurance. So a lot of software companies, they have their full-time software quality assurance departments. In fact, one of my first jobs was working as a manager for a software quality assurance department, where, well, actually not a manager. I was actually I started as a regular software tester, and then there was a manager above me, and then it became my job to aggregate all the reports from testers, meaning from people who are testing different pieces of software. So this is again something related to quality, a very essential step. And then once the system is tested by technical specialists, meaning IT specialists, you have system testing by users, by end users. There is something called user acceptance testing. Ensures that the system performs reliably and does what it's supposed to do from the perspective of a business user. Who will participate in user testing? Well, whoever will end up using the system. And this is a very important step because it's like a bottleneck, meaning if users accept your system, they feel the system is adequate, it's reliable, secure enough, it addresses their needs, then in a way you have some assurance that the project has been successful. However, sometimes no matter how much money you invest, no matter how perfect the system is from a technical standpoint, users may say, look, it simply does not address our needs. We cannot use it, it doesn't seem to be appropriate for our daily jobs. Again, using the ERP implementation at Natural Spring as a case, that's exactly what happened. At some point, users said, "Look, the system." They told the CFO that the system that you're proposing, is good, but it just doesn't address our needs. It doesn't. The system doesn't seem to be compliant, or is not compliant with the local accounting standards, so it's of no use to us. Okay, so very essential step: system testing by users to make sure that. The most important goal of this step is to make sure that users accept the system. Okay, friends, so that concludes part 4 of our video presentation on Chapter 9. Thank you for listening.